Hello students, in the previous classes we have discussed about the Ohm's law, experimental verification of the Ohm's law we have seen. Also we have solved some numerical problems. So while dealing with the Ohm's law, we have understood that current in the circuit can be adjusted by adjusting the rheostat. What actually the rheostat was doing? It is adjusting the resistance of the circuit. So if you change the resistance, the value of the resistance if we change, we can change the value of the current. So when we design a circuit, according to the need of the current, we have to adjust the value of the resistance of the circuit. So the materials which offers this resistance, they are called as resistors. So resistors or resistance wires will have very high resistivity. So we will be able to take a particular value of the resistance and can have a proper connection so that the current in the circuit can be adjusted. So you check in your textbook, you can find a table where the list of elements such as conductors, insulators and semiconductors given, and if you check the resistivity of these materials, conductors will have the least value of the resistance and insulators will have the highest value of the resistance. So, because of this lowest value of the resistance, conductors are called as conductors. So, when we go into resistors, resistors are not made with the pure materials, they are always made with the alloys. So, in the laboratory or in any circuit, if we want to use a resistor, the resistors will be made with respect to the combination of materials. So that part let us study afterwards. So in this class, how we can change the value of the resistance of a circuit by suitable combination. So the two combinations already I have told you while measuring the potential difference and current in a circuit, the way of connection of the device, voltmeter and the ammeter. You learned that voltmeter will be always connected in parallel. Ammeter will be connected in series. So anything connecting one after the other like beads in a chain, that is called as series connection. And as I told you, the pendant one over the other, if you make a connection, that connection can be called as a parallel connection. So let us see how theoretically we can study this. So I will be teaching you today combination of three resistors, first in series and next in parallel. And in series, the what will be the total current or what will be the total resistance, that we will see. Similarly, parallel also what will be the total resistance. So this equation I am going to derive. So let us consider three resistors named R1, R2 and R3 connected one after the other as shown in the diagram. And name of these resistors, let us take R1, R2 and R3. All these are connected in series. How can we say that this is series? Because the tail of the R1 is connected to the head of the R2. Again, tail of R2 is connected to the head of R3. Therefore, end-to-end connection. So we can say that this is a series connection. And it is connected to a battery of, let us mark V volt, and the battery is connected to a key. The key is connected back to the resistor R3. So this is an open circuit. If you want to make the current flow through a circuit, as I told you, you have to put a dot mark here. Now this is a closed circuit. So this is a simple circuit having three resistors R1, R2 and R3 connected in series to a potential difference of V volt. So now let us mark the direction of the current. Current will always start from positive terminal. It will reach R1, it will reach R2, it will reach R3, it will come back through the key and reaches the negative terminal of the cell. And when it is flowing like this, you can see that it is a straight flow. The I current, if I mark here, I current will flow through the entire circuit. R1 will also take I current, R2 will also take I current, R3 will also take the same amount of the current and it will reach back to the negative terminal. But look at the value of V, how this potential difference is connected. So what will happen to this potential difference? If you look at the circuit, the positive terminal is connected to the first head of R1, but its tail is not connected to the negative terminal. Therefore, this R1 totally will not get the value of V. And on the other side, what is happening? The end of the connection, that is from R3, the negative terminal is connected. So, what kind of a division will happen here? So, entire circuit is getting V value. So, this R1 may take a value named V1 according to the current flowing through R1 and its value of R1. R2 may take a value V2 depending on the value of its resistance. R3 may take V3 depending on the value of R3. It depends on the value of resistance because the current is same. So to get the value of net resistance, let us take the division of the potential difference. Here what is dividing? Potential difference is dividing, current remains same. Therefore let us start with the equation of V. So V is shared. So how V is shared? V is shared as V1, V2 and V3. So the net V or the total V, what we have given, we can take as the sum of V1, V2 and V3. Therefore, V1 plus V2 plus V3 will be equal to V. And what the Ohm's law, you have studied, what is the Ohm's law's equation, mathematical equation? Yes, V is equal to IR. So that you have studied. Therefore, this V is the total potential difference of this circuit. I is the total current. If I mention the total resistance of this circuit as RS, this S stands for the series connection. So, let us take RS as the total resistance of this circuit. Therefore, this V we can write as I into RS according to Ohm's law. Similarly, V1 you can write as I is the same through R1. Therefore, V1 is equal to I into R1. V2 you can write as I into R2. And V3 you can write it as I into R3. See this equation. This is simple Ohm's law. V is the total potential difference. Therefore, you have to include total current and total resistance. I just mentioned total resistance of the combination as R series, or you can say it as R effective when three resistors connected in series. V1 is I into R1 and V2 is I into R2. V3 is I into R3. Why I is same? Because this is a series combination, current through each resistor remains same. And only the value of V is getting divided. So I is common for every terms here. So if you cancel I, what we will get? RS. So RS denotes the total resistance of the circuit, which is equal to R1 plus R2 plus R3. So this is an equation for the resistance, effective resistance, or the total resistance when three resistors are connected in series. Suppose if these resistors are equal, R1 is equal to R2 is equal to R3, equal to R. Then RS will be equal to how much? R plus R, which is equal to 3R. Therefore, if n resistors are connected in series, you can say n resistors connected in series, we can say that the effective resistance will be NR. N number of equal resistors connected in series, then the effective resistance will be NR. If 3 is connected, it is 3R. Therefore, 4 if you are connecting, 4R. Provided R1 is equal to R2 is equal to R3. If that condition, if it is satisfied, then we can say that the effective resistance will be equal to NR, N times the value of the resistance. So other side, let us see the other combination. What is the other combination? It is the parallel combination of resistors. So in parallel combination, we have to make one over the other connection. So let us mark this as R1, R2 and R3. All the heads connected to one common point that can be connected to the positive terminal. The negative terminal through a key can be connected to the other end. This is V volt. Observe the difference. Compare these two circuits. Here, I current will flow, I current will reach here. Compared to this side, I current was passing through the same, all the elements in the same way. But here, the current which is coming here, like water flowing in from a big pipe to the different pipes which is connected. This current after reaching here, it will start dividing. How it will divide? If R1 is offering R1 resistance, the current through R1 you can mark it as I1. R2 is the resistance of the second one, the current through it you can mark it as I2, and similarly I3 can be the current through R3. Now what will happen to this value of V? The V will be remaining same for all. Will it be? You look at this circuit. The one end of the resistor is connected to the positive terminal. The other end of the resistor is also connected to the positive terminal, negative terminal. So this resistance R3 is getting positive terminal directly as well as the negative terminal. So it is getting V volt. Compared to this R2, it is also connected directly to the positive and directly to the negative. This will also get V volt. And R1, it is also connected to the positive terminal as well as the negative terminal. Therefore, it will also get the same value of potential difference. So compare these two circuits. Here what is dividing? Here the current is getting divided. Potential difference is getting divided. Here what is dividing? Current is dividing. Here what is remaining same? Current is same. Here what is remaining same? Potential difference is remaining same. So a series circuit is a circuit in which current remains same. A parallel circuit is a circuit in which potential difference remains same. So a series circuit is the one in which the potential difference is getting shared. A parallel circuit is the one in which current is being shared. So we have to start with the equation what is being shared. So here we started with the V which is shared. So here you have to start with the current which is sharing. So I is equal to I1 plus I2 plus I3. I is equal to I1 plus I2 plus I3. What is our next step? Substitute for I, I1, I2, I3 from the Ohm's law equation. So from the Ohm's law equation, what I is equal to? I is equal to V by R. So this total current in the circuit, you should replace with the total potential difference. Here there is no problem, potential difference is remaining same. V divided by, let us put the total resistance of the circuit marked as Rp. Why I have marked with the Rp? Here series total resistance I marked as Rs, denoting this is a series combination. Here it is parallel, therefore I marked it as Rp equal to I1, we can write it as the potential difference divided by its resistance V by R1. I2 I can write it as V by R2 and I3 I can write as V by R3. So what is common here? V is common, therefore V we can cancel throughout. So what we will get? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation for the effective resistance of 3 resistors connected in parallel. You see, when 3 resistors connected in series, the equation is Rs is equal to just the sum R1 plus R2 plus R3. But the same resistors, when they are connected in parallel, the reciprocal of the total resistance or reciprocal of the effective resistance is equal to the sum of the reciprocals of the individual resistances. Sum of the reciprocals of the individual resistances will give the reciprocal of the effective. So this is becoming a little complicated. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. After finding the right hand side, when you solve numerical problem, don't forget that it is 1 by Rp, but the effective resistance is Rp only. Don't forget to take the reciprocal of your answer. Then only you will be getting the value of the effective resistance. So what is the conclusion? Whenever 3 resistors are connected in parallel, reciprocal of the effective resistance is equal to the sum of the reciprocals of the individual resistors. Let us come to the case like this. If R1 is equal to R3 is equal to R, if all are of same value of resistances, if R1 is equal to R2 is equal to R3 equal to R, then what will happen? 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R. If you take the LCM, LCM will become R, numerator 1 plus 1 plus 1, that will be 3. So what is our equation, what is our real value of effective resistance? It is not 1 by Rp. Our real value of the effective resistance is Rp. So Rp will be equal to R by 3. That's why I told you, don't forget to take the reciprocal, R by 3. So if 3 resistors connected in parallel, if we got the effective resistance Rp as R by 3, if you connect n number of resistors, if 3 instead of 3, if you are connecting n number of resistors, then this Rp will be equal to R by n. So n number of resistors connected in parallel, the effective resistance is Nr, whereas in parallel the effective resistance is R by n. Suppose if you have 3 5 ohm resistors, so 3 5 ohm, number is 3 and resistance is 5. So if they are connected in series, what will happen? 3 into 5, you will be getting 15 ohm. If the same connected in parallel, R is 5 and N is 3. So what will be 5 by 3? 5 by 3 is definitely 1 point something. So it is a less value. So one conclusion is that whenever a number of resistors are connected in series, the effective resistance will be very high, more than the highest value, more than the most. Whenever a number of resistors are connected in parallel, the effective resistance will be less than the least. So to reduce resistance in a circuit, we can have parallel combination. To increase resistance in a circuit, we can have series combination. So in series combination, the net resistance will be more than the most. More than the most means highest value. Suppose if you have 3 resistors, 1, 2 and 3. 1 ohm, 2 ohm and 3 ohm connected in series. So if they are connected in series, what is RS? RS will be 1 plus 2 plus 3. How much it is? 3 plus 3, which is equal to 6 ohm. When they are connected in series, the resistance will become 6 ohm. The same thing if you connect in parallel. RP, if you are connecting, 1 by RP is equal to 1 by 1 plus 1 by 2 plus 1 by 3. If you solve, it will be lesser than 1. So 1 by RP is equal to 1 by 1 plus 1 by 2 plus 1 by 3. So if you take the LCM, 6. So 6 plus 3 plus 2. So 11 by 6 or RP is equal to 6 by 11. 6 by 11 is lesser than 1. How much it is decimal? 0.5 something ohm you will get. So when you connect, see the value, effective is 0.5 ohm. This 0.5 is less than 1. Is it so? 0.5 is less than 1. But this 6 is more than 3. So that's what I told you. Whenever a number of resistors are connected in series, the effective resistance will be more than the most. Whenever a number of resistors connected in parallel, the effective will be less than the least. So 1 ohm, 2 ohm, 3 ohm connected in series, it will be definitely more than 3 in series. It will be definitely less than 1 if it is parallel. So to reduce resistance of a circuit, we can have parallel combination, and to increase resistance we can have the series combination. So these 4 equations you should be very neatly studying. Rs is equal to R1 plus R2 plus R3, and if all are of equal value, Rs is equal to NR. If it is a parallel combination, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If all are of same value, Rp is equal to R by N. So study these 4 equations, and I shall show you some activity. Activity 4, realizing what way this kind of series combination and parallel combination is practically useful in our day-to-day life. So here, as I told you, the potential difference is getting shared. There the potential difference is remaining same. So here you see, if I disconnect this R1, suppose if I disconnect, whether the current will flow through the circuit? Yes, your common sense you can say that no, current will not flow. See, if I connect only, the current will flow. So one of the device or one of the resistors, if it is got disconnected, then the entire circuit will become functionless. But on the other side, if I disconnect this, the current will flow through the other two can work. So that is the speciality of the parallel combination of a circuit. So I shall demonstrate it through an activity, and after seeing that activity, we can understand how best a parallel combination is for our household connections and how it is not that good for the series combination for making a household connection, that you can realize through the activity. So let us see an activity. Or if you look at this arrangement, you can see 3 bulbs. So if you keenly observe the connection, the first bulb is connected to the second bulb is connected to the third bulb, the black wire you can see, and the last bulb, the green wire, is again connected to the power supply. So what will happen here? This is connected one after the other. So as you have learned, end-to-end connection. So that means it is a series connection. So imagine these bulbs and their resistance as R1, R2 and R3. So this you can compare with the 3 resistors connected in series. So compare these bulbs connected with the resistors, and what are the drawbacks or what are the advantages or what are the specialities of this kind of a combination and why we can prefer the other combination over this. All these things we can analyze through this activity. So all these bulbs are connected in series. Let us switch on the power supply. So I have switched on the power supply. At a time, all the 3 bulbs started glowing. So look at the illumination of the bulb. So when you see the other combination, you can realize why this is so. So as you have learned the theory, when number of resistors connected in series, the current will be remaining same, the potential difference will be shared. So total, when you have given 15 volt, if 3 bulbs are identical, each bulb will get a 5 volt. So that is the speciality of series connection. So when these are connecting in series, the current is same, but the potential difference is getting shared. So when the potential difference is getting shared, the bulb glows will be very less compared to its capacity. Why it is so? Because each bulb will not be able to get a desired voltage of its characteristic feature because the voltage is getting shared. And observe, if I remove one of the bulbs, what happened? All the 3 bulbs stopped glowing. Why it is so? When you remove one of the bulbs, so one of the resistor, if we are getting disconnected, the entire circuit is getting disconnected. So this kind of a series combination we will not prefer in the case of a household connections, because one of the device, if it is going faulty, the entire circuit will not function, or one bulb get fused, the entire connection will not be functioning. Therefore, this kind of a connection will have 2 kinds of drawback. One is we cannot have separate switches for this kind of a connection. We cannot have the equal division of desired potential difference for each devices, and one device, if it goes faulty, then the entire circuit will not function. So due to this reason, we will not prefer this kind of a connection for the household connections. In your home, the connections will be parallel. On the other side, you check a parallel connection. You see this kind of here the connection. If you observe all the bulbs, see the first bulb, the black wire is connected to the second bulb is connected to the third one. Again, the other end of the third bulb is connected to the first, and the second to the first one, like this. So all the bulbs directly connected to the positive and the negative. So this kind of a connection, as we have seen in the 3 resistors connected, this is also a parallel connection. So if I switch on, these 3 bulbs are of same characteristic feature as the other 3 bulbs which I have shown you. And now you see, if I switch on this, see the glow? All the 3 bulbs glowing with a large amount of luminosity compared to the previous case. So can anybody suggest what is the reason? What may be the reason? So same bulbs, same kind of a power supply I have given, same voltage I have given, and in this kind of a connection, the bulb is glowing with a much more luminosity. The reason is each bulb is getting equal value of potential difference. The current is shared according to their capacity, and all the bulbs are getting same amount of potential difference. They can glow with the maximum capacity of that particular device. And at the same time, if I remove, I disconnected one bulb, you see the other 2 bulbs are glowing. So that what is the meaning? You can have separate switches for one of the bulbs, and the other 2 devices also can work. So this will not hamper the circuit if one of the devices is going faulty. So we can have separate switches, we can have equal potential difference for all the devices, and devices will divide the current according to their need or according to their capacity. See, if I remove the second one also, the other one can glow. So this kind of a connection, which is called as parallel connection, this is preferred for any household connection. The reasons: we can have separate switches, all the devices will get the same kind of potential difference. So according to the capacity or power of the device can have equal amount of the current can be divided, and it will be glowing with its maximum capacity. And if we are giving one of the faulty device in the circuit, that will not affect the functioning of the remaining devices. That is an added advantage. So all the household connections, the electric connections will be in parallel.